The next thing we're going to talk about is parametric equations. Now we're going to return to something that we've already done. If we have points x1, y1 and x2, y2, and we want to find the condition for a point xy to lie a proportional distance t of the way from x1, y1 to x2, y2, we're going to construct the fundamental triangle in the similar triangle here. The proportionality of the similarity is t, and we end up with this. And we've seen this twice already, so I'm not going to go into a lot of explanation. The point is that if we do this, and let me back up a second. When we did it before, we let the proportion be t. Now we're going to let it be t. We're going to interpret it in some cases as if it was time. Okay? We end up anyhow with x equals x1 plus x2 minus x1 times t, y equals y1 plus y2 minus y1 times t. Again, you should be familiar with that from your knowledge of what we've done previously. These equations are called parametric equations for x and y. T is called the parameter. Okay, a parameter is just a variable. It's something that can vary over a lot of different values and give us a lot of different values for x and y. So we have parameter t acting on these equations to give us different x and y coordinates. And if we plug in any t, we'll get an x and a y. The x and the y that we get is going to lie somewhere along the line that connects x1, y1 with x2, y2. Or more generally, along the line through these points. So if t equals 0, for example, now let's just see. If t is 0, well, of course, that means we're 0 the way from x1, y1 to x2, y2. So we better be at x1, y1. Let's see. If we let t equals 0, then these terms are 0, and we have x equals x1 and y equals y1. So sure enough, t equals 0 gives us what we expect. If xy is proportion 1 of the way between x1, y1, and x2, y2, that means it's all the way to x2, y2. Now, if t equals 1, what do we get? x1 plus x2 minus x1 is x2. y1 plus y2 minus y1 is y2. So that x is x2, y is y2, so the point x2, y2 lies at the t equals 1 point of the graph. The t equals 1/2 point, well, you can work out the details, but that's going to be the midpoint. So t equals 1 here, t equals 0 here, t equals 1/2 here. We could also go to t values greater than 1 or less than 1. If t was equal to 2, then we'd be proportion 2 of the distance from here to here. That means we'd be twice as far from this point as this one is, which means we'd be out here somewhere at about twice the distance. So our t equals 2 point might be here. We could have a t equals -1 point over on this side. And by letting t take all possible values from -infinity to infinity, we get the whole line. So that what we have here again is a set of parametric equations. If t is allowed to take all possible values, we get all the points on the line defined by x1, y1, and x2, y2.